trig in the coordinate plane. So we have a point here, and we're gonna plot it on the coordinate plane, and we're gonna figure out the angle that it makes if it were if the line from the origin to this point is the terminal side, as in like an angle of rotation. And so that's going to look like this. And negative 1520 is going to be, let's just say this is negative 15, and then up 20. We'll put it there. And if you draw a line from the origin, this could be a terminal side. It's gone all the way around here, but it if we treat this like a reference angle, and we know a couple things, then we could make a triangle out of this, and this would be side length, negative 15. This would be 20. We'd put theta here, and then this would then look like a reference angle. The distance from here to 180 would be a reference angle. So we're going to find all values of the 6 trig functions. And an easy way to do this right away is we need to know what this other side is. So we could just use Pythagorean's theorem. So we have 2 sides of a right triangle. So that would look like negative 15 squared plus 20 squared, and this is equal to C, the third side of the triangle. We'll call it R squared. So 15 squared is 225. And then 20 squared gives you 625 altogether. And this is R squared, so you'd get 25 as that third side. Okay, so what we want to do is, very basically, we could say that we know what sine, we want sine of theta, cosine of theta, and tangent of theta. That's the first 3 that we've always done. Then we're also going to do cosecant, secant, and cotangent theta. So this is sine of theta is opposite over hypotenuse. This is just SOHCAHTOA again. Wow, it's really hard to write. Okay, so sine would be opposite over hypotenuse. That's going to be 20 over 25. We can reduce that to 4/5. Cosine, I guess I'll show you what it is before we reduce it. Cosine is adjacent over hypotenuse, so it's negative 15 over 25, and that reduces to negative 3/5. Tangent is opposite over adjacent, so it's 20 over negative 15. That gives you 4/3, and it's negative. So this problem's not very bad, because once we find these 3, which was relatively easy, once we set up the triangle, it's going to be probably the hard part. To find the inverse, or the other trig functions, they're just the reciprocals. So this would be 5/4. This would be 5 over negative 3. This would be 3/4. And I'll put the negative out front. Typically, you won't put the negative on bottom. Usually, it's just customary to leave it on top, or you can put it out front. So we'll do that. And we did it. We found the values of all the 6 trig functions for theta in standard position if a point with the given coordinates lies on its terminal side. And so one key thing is that wherever you draw the point, wherever you put the point, at the ordered pair, you draw a line from the origin, because then now it looks like a terminal side of an angle of rotation. And then in order to call theta, to place theta, it's always going to be between the x-axis and the terminal side, effectively creating a reference angle. And then the only other line you need to draw is just what's kind of usually called an altitude. Just goes straight down to the x-axis and makes a right angle with the x-axis. Okay, so we can try another one. This will be a little bit different. So here's a coordinate plane. 6, -5 is going to be 6 over and down 5 because it's negative. So I drew the terminal side. This is all the way over here. And the angle theta is going to be always close to the origin. It's always going to be between the terminal side and the x-axis. And we connect our triangle right there. So the sides then are 6 and -5. Because this is like how far you went in the x-axis and how far down you went in the y-axis. You can find the third side by doing Pythagorean's theorem. So that's 6 squared plus a -5 squared. And we're finding r. So I get 61. But keep in mind that that's r squared, and 61 is not a perfect square, so we're just going to have to leave it as square root 61. And we can find our first three trig functions. So sine of theta is opposite over hypotenuse. That's -5 over square root 61. However, we don't like to leave the square roots on the bottom, so we're going to multiply by a fraction, square root 61 over square root 61. And all it really does is just it rationalizes the denominator, so we get a -5 root 61 over 61. Cosine of theta makes adjacent over hypotenuse, so the same thing is going to happen. We get 6 over root 61, and we'll do the same little dance over here with this guy, and it's 6 root 61 over 61. Tangent of theta. We can honestly do tangent before we even do Pythagorean's theorem, because we already had the two side lengths. Opposite over adjacent is -5/6. Then we could find cosecant of theta. It's just the reciprocal. Now I would just take this guy right here, the original one, because it's already set up. If we flip it, the root's already on top. So this would just be square root 61 over 5, and it was negative. Secant of theta, same deal. I would take the original fraction, square root of 61, and flip it over 6. And then cotangent of theta is -6/5. So that's two examples. Plot the point, draw a line from the origin, label theta between the terminal side and the x-axis, wherever you are. Make the triangle, find the third side, then you can get your 6 trig function.